All right. The early life exposures in Mexico to environmental toxicants, birth cohort, let's get this back on projection, is a collaboration with a number of different institutions, but the primary ones are the National Institute of Public Health in Mexico and the University of Michigan, where we built a lot of the collaborations. This was started when I was at Harvard. Still collaborators at Washington, Toronto, and elsewhere. There's various diaspora, I guess you could say, but we all managed to work together on this great project. I'm going to talk about the element birth cohort in relation to two particular risk factors. One is lead, and the other one is fluoride. Both of them are kind of controversial in their own way. Lead, on some level, is old news. It's probably one of the most studied toxicants of all in environmental health. But the basic message is that not only do we still have so many things we don't know about, in particular, the long-term consequences of lead exposure, but lead is also, because we know so much about it and the various mechanistic insights about how lead exerts its toxic effects, it actually is a wonderful continuing platform in which to explore other environmental health topics like toxicant interactions, like gene toxicant interactions, like what are the windows of susceptibility to an organism during the life stage to a neurotoxicant like lead, and so forth. So that's why NIH has continued to fund lead research, even though occasionally we'll get these reviews and studies section. God, we know everything there is about lead, don't we? Actually, no. Fluoride is an entirely different kettle of fish. And I'll mention a little bit about the politics of fluoride, because in distinction to the lead research, which has its own controversies. Actually, we've been sued twice for our data by the Lead Industries of America through the Freedom of Information Act. The fluoride situation is different because it's an example of one branch of public health, dental public health, which has been advocating for water fluoridation for over 30 years, with another branch of public health, which is us folks in environmental health, which is quite concerned about some of the toxic effects of fluoride. All right, let's get right into it. So much of this work, I have to say, has been a wonderful team science collaboration with folks from these institutions up in the upper right-hand corner, and now we're looking forward to building collaborations here at Keck. But basically, this has grown into a kind of an environmental and molecular epidemiology collaboration, with Element being one of the major cohort studies that we've been investigating. Another one is the normative aging study, and for that matter, the nurses' health study, that is a sub-cohort that lives in the Boston area. And all of this research has been mostly funded by NIH, some by the EPA, some by various foundations, the Marshall Dimes Foundation, among others, etc. Now, as I said, some would say, gosh, not only do we know everything there is about lead, but we've phased lead out of gasoline, we've taken it out of paint, so what's the big deal? Well, actually, lead is an example of one of the great environmental health success stories in this country. If you look at NIH data, particularly once lead was phased out of gasoline, you could see this spectacular decline in average blood lead levels in the NIH blood samples. And interestingly, superimposed are these quarterly failed sales figures for leaded gasoline, giving you a sense of just how important combusted leaded gasoline was as a vector of lead exposure in the US. And the average blood lead levels in NIH data now are somewhere around 1 microgram per deciliter, pretty darn low. But in fact, in the world, hotspots of lead exposure still exist all over, and average blood levels actually remain quite high. And hotspots are driven in some cases by these spectacular lead poisoning foci, like this in the state in, where is this? I think this is in Nigeria. I can't even remember now, where there's this smelter that's been emitting huge plumes of lead pollution, leading to clinical lead poisoning, and hundreds of children, 400, have died because of this. It involves Medicine Sans Frontières, et cetera. So, the press will highlight these big hotspots, but well beneath these hotspots are these large populations of people who are exposed to all sorts of other sources of lead exposure, mostly now in low and middle income countries, and I'm going to talk about that. Now, one of the reasons why we have studied lead so much is because we have to appreciate that lead exposure, once it's over, actually still lingers in the body for decades. And that's because lead actually substitutes for calcium in the hydroxyapatite structure of bone. And there it sits for many years. So there are these internal sources of lead exposure, on top of which the animal and experimental data tell us that, in fact, lead may have chronic disease impacts that we have to think about. And it's sort of like smoking, in fact. If you want to, if your uncle comes to you and says, gosh, I've been smoking for decades, you're in the health field. Tell me, what's my risk for developing lung cancer? And to help your uncle out, the question isn't, well, how many cigarettes a day do you smoke? The right questions are, well, how many years did you smoke? And on average, how many packs per day? And the right metric for actually estimating your uncle's risk for lung cancer is pack years. It's the multiple of years of smoking in packs per year. That's cumulative exposure. And the cumulative exposure metric is emerging as the most important metric for most of lead's chronic sequelae health effects over time. Well, measuring blood levels won't tell you what cumulative exposure profile is like. Because your blood lead level, let's say it's elevated, let's say it's 20 micrograms per deciliter, well above the child standard, but below, by the way, the current occupational standard of 40. You have no idea whether the individual's had a blood lead of 20 for 3 months or 30 years. It's not a cumulative exposure metric. And this nice schematic, which when I first saw this, I thought it was a depiction of the bureaucracy at EPA, which, by the way, is very convoluted. But what this is a pathway of sources of exposure for lead. And the basic message is that if you want to understand what someone's lifetime exposure was to lead, you can't administer a questionnaire. I mean, it's impossible. The sources are too numerous, they're silent, most people have no idea what it is. So you have to come up with some other way of estimating cumulative lead exposure. So what do? What our team did was work with these MIT scientists to develop a way of measuring directly the amount of lead in bone. Because as I mentioned, 99% of lead that's you're exposed to and that accumulates in the body goes to bone. And those bone stores last for decades. So it becomes a cumulative dosimeter, if you will, of what your lifetime exposure was to lead. And now there's a bunch of different research facilities that have this technology at Harvard, Hopkins, Cincinnati, Pitt, Purdue, and a few other places. On top of it being a cumulative dosimeter of what your lifetime exposure was to lead, we now have to anticipate that there are certain times of life when your skeleton is literally dissolving itself, like osteoporosis. We get old. And in particular, women in the postmenopausal state are undergoing a lot of bone dissolution. So we're worried about that. But the other state is pregnancy. Because at that time, your women's skeleton is literally dissolving itself to support the growth of the skeleton in the fetus. And is it possible, the question has to be asked, that even though a woman who is pregnant is no longer exposed to lead, but has had lifetime exposure to lead from growing up, is she risking her fetus for lead exposure because of mobilization of lead stores? And that was actually the origins of the element study, to try to understand it. Now, before I go to the element study, let me digress a bit and tell you what happened once we developed this cumulative dosimeter of lead, which is that we first applied it to chronic diseases of aging, leveraging the normative aging study, as I mentioned at the beginning. And this is what the data looks like if you measure these subjects, who are basically community exposed men, most of them veterans, recruited from all walks of life in Boston. Some are policemen and firemen, toll booth collectors, teachers, some doctors and lawyers. But as you can see, although none of them worked in what could be considered a lead industry, like smelting, the bone lead levels were widely distributed depending on age. And as you get older, of course, this is trending upwards, which basically is the cohort effect of older people being exposed to more lead during their time as adults, and also the cumulative effect of lead going into bone. And so now we have this dosimeter. You can see it varies widely. What happens when you use this new biomarker to predict toxic effects? So before we get there, I thought it's worth mentioning that this is also a new dosimeter that can be used to understand disparities. And here's an interesting study we did in which we showed that if you compare whites and non-whites, and then within those categories compared those who were white collar status versus blue collar status, the disparities between white and blue collar status are much greater among non-whites. Why? Well, probably because non-whites in blue collar jobs got the dirtier jobs. And that's a sociological phenomenon we see, actually, if we look at the occupational sociological literature. And here's biomarker evidence of that very fact. Okay, so when you use this as a biomarker for looking at chronic effects, this is one of the early studies we published showing that bone lead levels, unlike blood lead levels, which, by the way, in the normative aging study were all low, they're well under 10 micrograms per deciliter, and they didn't predict anything. But the bone lead levels were highly associated with having developed hypertension. And interestingly, the effect was much stronger than that of age. Why is that interesting? Well, you know, in medical school, and even now, when you train as a clinician, you're taught, oh, you know, as you get older, inevitably your blood pressure goes up with age. It's not true. Actually, if you look at a non-industrialized population, like the Bantu in South Africa, the blood pressures when you're 50 years old are not that different from when you're 20 years old. And then when you do the migration studies and follow them as they go and migrate into cities, then you see the blood pressure starts rising with age. So there's something about the urban modern environment that causes blood pressure to increase. And we never really knew whether it was nutrition, change in lifestyle, sedentary lifestyles, noise. But here's a biomarker study telling us, in fact, that lead is actually probably one of the major risk factors that results in increasing blood pressure with age. We found the same thing when we looked at bone lead as a risk factor in a study of the nurses' health study of nurses who lived in the Boston area. And none of these folks, you know, you would conceive were occupationally exposed to lead, but they were exposed to the same sources of lead that you and I were. combusted leaded gasoline that we sucked up and stored in our bones over the decades. By the way, I measured my own bone lead levels. They're measurable for sure. And then, we used lead in food cans right up until the mid-1970s. Of course, we used it in paint. It was in house dust in the houses that we grew up in. Our sources of lead were innumerable, as that earlier depiction of sources of lead exposure showed. So same thing, if you happen to be in the highest quartile of bone lead among the nurses, you've doubled your risk of developing hypertension. That's controlling for all the usual things we control for in these epi studies. And then we have enough follow-up of these men that we had baseline bone lead levels in the early 1990s, followed up of what they died of for the next 10 to 15 years, and shown that bone lead levels were very strong predictors of death from ischemic heart disease, cardiovascular disease in general, all-cause mortality. And interestingly, it was not a strong risk factor for cancer, which actually was encouraging to us because most of the rest of the literature shows that lead is not actually a human carcinogen. So this is like a control disease, basically helping us to feel confident that this lead impact in cardiovascular disease was real. Then we have looked at all sorts of measures of cognition using as a tool the mini mental status exam, which is a pretty crude tool. It's a 30 scale tool. It's actually the tool that we suspect Trump used, to say, oh, my brain works okay. It has a 30-point scale. If your cumulative score falls below 25, then we ship you off to the neurologist to get screened for Alzheimer's. But basically what we showed is that, yeah, if your bone lead is higher, you will have worse scores on this measure of cognition. And in fact, comparing the interquartile increases in bone lead, you see a 0.3 point steeper decline in bone lead equivalent to 5 years of excessive aging. That's not very good. And these kinds of effects actually duplicated by the Hopkins group, which did the Baltimore memory study and used the K-X-ray fluorescence tool to measure bone lead levels. And a bunch of other studies done by colleagues persuaded this expert panel in the CDC to conclude that the evidence is now sufficient that lead causes hypertension and cardiovascular disease and accelerated declines of cognition. And this is behind the recommendations made by this expert panel, which I happen to be on, which is that the OSHA standard is way out of date. It still allows people to have blood levels of 40. I mean, that's 10 times greater than what the normative aging study folks were exposed to in the general population. But unfortunately, that standard still has not changed. Oh, and that's a whole political story that we can talk about at some point. And here's some other things we looked at. We did case control studies showing that bone lead is a risk factor for amyotrophic lateral sclerosis, Parkinson's disease, and so forth. And basically what lead seems to do from the experimental evidence is that it accelerates all these pro-oxidant changes that occur in the brain and the kidney and other organs through a reaction called the Fenton reaction. And it's really interesting phenomenon that needs to be understood. Now, let's get back to element studies. So we're worried about the mobilization of lead from bone during pregnancy. And my collaborator, Mauricio Hernandez Avila, who was at the National Institute of Public Health in Mexico, wrote this commentary some almost 20 years ago. And then we proceeded to study this in element. And element turns out was an ideal population to study this because it phased lead out of gasoline much later than it did in the US, meaning that the blood levels remained pretty high, pretty low. The Mexico phased lead out of gasoline beginning in 1990. The US phased it out in 1975. So it meant that once we started this research in the mid-1990s, the blood lead levels had come down nicely, but the bone lead levels are still very high, about 3 to 5 times higher than they were in the US. So we had this opportunity to disentangle the effects of ongoing acute lead exposure from accumulated lead exposure from the past. And that's the design of the element study. What did we find? Well, we built this whole facility. We measured bone lead levels in women who were pregnant. They gave birth. We followed the children and measured all their neurobehavioral sort of outcomes. Among the first things that we found out when we looked at just perinatal outcomes is that bone lead levels predicted lower birth weight. That's even after adjusting for blood lead levels in mom or the cord blood lead levels and the usual covariates to adjust for in studies of birth weight. Okay, that's not so good. And then when we followed the offspring, we found that the offspring performed worse on the Bayley scales of mental development, even after, according to quartiles of bone lead, even after adjusting for the children's blood lead levels and the usual things that one adjusts for measures of cognition. So that's not great, because that means that the CDC's recommendations that we measure blood lead levels in kids is a missing part of the story, which is what happened during pregnancy. And this kind of research has continued. We also did this study, which is trying to look at the different windows of susceptibility during pregnancy and using a different biomarker, which is plasma lead levels of lead at each trimester of pregnancy. Now, why is that important, plasma? Well, it turns out that the lead that's available to cross the placenta is not the whole blood lead level. It's the lead that's in plasma, that's free, ionized, or loosely bound to proteins and able to cross the placenta. Now, turns out that most lead that's in a blood sample is actually attached to the red cell, and it's not free to cross the placenta. Now, if the equilibrium between plasma lead and lead that's attached to the red cell was perfect, in other words, you can measure a whole blood lead level and it would tell you what the plasma fraction was, then you wouldn't have to measure plasma lead. But as it turns out, we've done the research to show that it's not perfect. In fact, the ratio of what's in plasma versus what's in a whole blood sample could vary by a factor of 5. So we worked with Don Smith at UC Santa Cruz to develop a whole different methodology to measure lead in plasma, which you can't measure with standard techniques for 2 reasons. One of them is that the level of lead in plasma is well under 0.1 micrograms per deciliter. It's really low, so you have to use specialized methods, and we're using sort of this special ICP-MS method. And the second is that if you don't collect the blood sample and process it using specialized means, then you're susceptible to contamination of the plasma sample from lysis of the red cells. So we developed a whole method for drip collection of the blood, low-speed retrocentrifugation, special collection of the supernatant for plasma, and on top of that, we would measure hemoglobin using a Cripps assay in the plasma to make sure that there isn't any sign of contamination from lysis of red cells. So when we do that, now we have this new biomarker of plasma lead, and we showed that, in fact, the first trimester of plasma lead measurements were much more influential than the second or third trimesters in predicting the Bayley scales of mental development in age 2. Not great news, because it means that, if you wait until you know that you're pregnant, it's already too late. because that's already the first trimester is already almost over, and that has persuaded the CDC to actually recommend all sorts of preventative methods for the mobilization of lead from bone. We also, and this is very exciting to us, showed that maternal bone lead levels were a major predictor of the offspring blood pressure at age 7 to 14. And that sort of gets at the Barker hypothesis, which is what are the prenatal determinants of adult outcomes like hypertension. And as it turns out, the blood pressure at age 7 to 14 is very highly correlated or highly predictive of risk of developing hypertension as an adult. So we're, and one of the things we discussed earlier in this morning, we're very excited about research on hypertension using prenatal risk factors and understanding the role of that. We think the mechanism might actually be epigenetic programming. And then from a global perspective, and this sort of shades into the global burden of disease discussion, we have done projections of what the bone lead levels are like all around the world in these 16 regions. And here's, let's see, where's the Americas? That would be, I think this is us. No, that's North Africa. I think this is us. Up here, bone lead levels in the high-income countries are still relatively high, but they're much higher even, we would predict, in Latin America, in parts of South Asia, in the Caribbean, because of the long-term use of leaded gasoline, but also other sources of lead exposure around the world, with blood levels still elevated around the world. So there's going to be a long tail of lead impacts on worldwide cardiovascular disease, cognition, and other things, even though lead's been phased out of gasoline many years ago. All right, and then in element, there's been a whole bunch of other things that we've studied. We've studied gene-environment interaction. We've measured all sorts of other contaminants, pesticides, phthalates, other metals. Now we have GIS associated measures of air pollution. We've done 2 randomized controlled trials showing that we can actually reduce lead exposure during pregnancy to the fetus by use of 1,200 milligram calcium supplements taken at bedtime, and other research. We're very excited about the epigenetic stuff. This is just an example of an epigenetics paper published by our group a few years ago, showing that there's various epigenetic potential signatures associated with various contaminants, this is the kind of research we hope to be doing in collaboration with some new collaborations here at USC. A brief mention of our fluoride work. This is one of the most controversial areas in environmental health, I have to say. We got into this because of this 2006 study done by the National Academy of Sciences, which basically suggested that, gee, we may have to worry about neurodevelopmental toxicity, but most of the studies that have been done were ecological. There was a 2012 systematic review of all these ecological analyses done by Philippe Grandjean and colleagues, which basically concluded that the results supported the possibility of adverse effect, but all this research was mostly ecological, and we needed detailed individual biomarkers of exposure. And that's exactly what we did, because we realized we had all these archived urine samples taken at each stage of pregnancy that we can do these state-of-the-art measures of fluoride on. We did that with our colleague from University of Indiana, Angelise Martinez-Meyer. She runs the premier fluoride biomarker laboratory in the country. We found that our maternal creatinine-corrected urinary fluoride levels or about 0.88 milligrams per liter. And that was comparable to the levels seen in fluoridated communities and women in Canada. They had mean levels about 0.69 versus non-fluoridated water with a 0.40 mean levels. And then we conducted the very first large biomarker study of prenatal fluoride exposure and cognition, showing that in fact we could see a clear signal of prenatal fluoride exposure being correlated with lower scores on a number of different intelligence scales. This is a whole summary of the baseline regression model with all these different sensitivity analyses, because believe me, when the editors realized how controversial this was, they put us through 3 rounds of sequential reviews with a total of 45 pages of critiques. And we did all these supplementary analyses, including more in the supplementary tables, to try to satisfy the anxieties of all of our reviewers about publishing this work. We got through all that, found very consistent results. Here's what some of the scatter plots look like of maternal fluoride and IQ. Actually, for some of this work, we could see, this is the McCarthy scales of intelligence, this is the Wechsler scales, and there was a hint of a potential threshold here, but really not enough data to address that. But the dentists, after critiquing our study and saying it was trash, got all excited, saying, well, even if it's true, there might be a threshold, and we can still put fluoride in water because we need to protect everybody's cavities, teeth from cavities. And, it's just this huge controversy. And the mechanistic data is there. I mean, fluoride has all sorts of ill effects in these experimental models of neurotoxicity. But as you can imagine, this got lots of press, got attacked by the American Dental Association, who drew up this whole list of limitations and criticisms, some of them reflecting a basic misunderstanding of environmental epidemiology. And one of their main criticisms is that there's no reference values for urinary fluoride in pregnant women. And then the Myrick study published that stuff on Canadians, showing that, well, actually, the levels are comparable. This is that study published by the Myrick colleagues in Canada, showing that the levels are actually pretty close to what we had in Mexico. We also showed that the urinary fluoride levels predicted higher anxiety on these scales of ADHD, that was also produced a lot of flack. And in the new R1 that we're planning for the competitive renewal, we're looking at a whole bunch of other outcomes related to cognition and non-cognitive outcomes, basically capitalizing on a conceptual diagram of how toxicants might actually impact education, as well as these life outcomes related to employment and socioeconomic status. So, gosh, that's already a lot. I need to just tell you about this initiative. In 2017, the Lancet Commission came out with a new analysis using the global burden of disease data. And those of you who are familiar with the GBD will know that this is one of the largest scientific collaborations in the world, which basically tries to measure impacts of all sorts of risk factors, as well as looking at different metrics of disease burden in every country of the world using standardized metrics. This is funded by the Gates Foundation and is all based in an institute at the University of Washington. But in this 2017 Lancet Commission, we coalesced everything that related to the pollutants that were entered into the GBD to show that household air pollution was responsible for an estimated 3 million deaths per year, ambient air pollution responsible for 4 million deaths per year, poor sanitation in terms of water responsible for 1.7 million deaths per year, chemicals and heavy metals, not including lead, responsible for over 1 million deaths per year, and lead alone responsible for over 500,000 deaths per year. And you put it all together, and pollution measured in the GBD was responsible for an estimated 9 million deaths per year in 2015, 3 times more than AIDS, tuberculosis, and malaria combined. 16% of all deaths worldwide. When this commission report was released in 2007 in the Lancet, it was kind of a wake-up call. It sort of was featured in Davos. It was presented at the United Nations, because pollution really hasn't been on the radar screen for most of the health policymakers. And all of a sudden, a whole effort was started. Well, let's start off with air pollution. God, it's just this huge impact. We got to do something about air pollution. But in fact, and this is, I'm going to skip this slide. We know this because this is the epidemiologic transition, right? We know that pollution is part of the modern ills, which is contributing to the increasing burden of disease, whereas the traditional risk factors, infectious disease and nutrition, are declining. Main drivers being urbanization, globalization, motor vehicles. But that's just accounting for air pollution, water, sanitation, lead, and radon. That's it. There are no other environmental risk factors in the GBD. How about mercury, arsenic, pesticides, flame retardants, and climate change? Right? And that's why this initiative formed, which is, let's figure out how we can get all these other things into the GBD, because the GBD has emerged as a major policy tool that folks are using all over the world, and particularly in low and middle income countries, as they strive to meet the sustainable development goals. They all have to make these decisions about what they're spending their budget on. And pollution should be part of that. So this is a collaboration, that was discussed at a major workshop back in 2018. And basically, this workshop launched this initiative, and the whole goal of the initiative to improve estimates in the GBD of the pollutants that are already in there, because there's still lots of problems with them, and I'll discuss some of them in a moment, to get new chemical pollutants into the GBD. And ultimately, we need to also account for climate change so that we can put the evidence on the radar screen of the policymakers, so they can make the right choices. What this workshop did was identify the challenges of getting new things into the GBD. And one of the biggest ones was just estimating exposures where there is no data. And what I'll show you in a moment is that the GBD has tools for estimating air pollution that are pretty good all over the world. For something like lead, they're just basically kind of guesstimates, and I'll show you how they did it. And there's all sorts of other challenges to getting new things into the GBD. A lot of these challenges are summarized in this paper, which I encourage you to look at if you're interested in this initiative. This represents the folks who participated in the workshop, including some of our friends at NIH and many of our collaborators around the world. And basically, the task is to try to assess these exposures and also try to capture the variability in these exposures by age, sex, seasonality, national and subnational geography. And actually, as I mentioned, for air pollution, we're getting pretty good at it because we have all these remote sensing techniques for trying to look at air pollution where there is no actual air monitoring data. And that's captured in some papers, some recent papers like these, satellite remote sensing for epidemiology. But here's just using lead as a case study, which already is in the GBD. How well can we estimate some of these other exposures? Well, the way the GBD does it is that it makes these assumptions. And the biggest assumption is that the major source of lead exposure worldwide all stems from the use of leaded gasoline. So even though leaded gasoline hasn't been used for years, we phased it out in a major global campaign with the last few countries phasing it out about 5 years ago. We can expect that there's still lead and dust from combusted leaded gasoline, and it gets entrained into the food system, and that's one of the best ways we can estimate population lead exposures. Well, how good is that? Turns out it's probably not that great. And what we did with a few collaborators here in this paper that's now under review is actually went back to the literature and looked at every published study there is in low and middle income countries. We found 34 countries that had adequate published data for estimating blood level. And we found that of these countries representing 631 million children, 49% of them probably have blood levels greater than 5, which is higher than the current estimates by the GBD. So we need to actually find partnerships to actually do this kind of research and make better estimates. And the biggest sources aren't a big mystery, in fact, because if we look at where the point sources are, we can understand that there's been this huge migration of big lead polluting industries like the automobile battery industry and the smelting industry, a classic example of the exportation of hazardous industries, and also the exportation of e-waste, which contains lots of lead, to all of these low and middle income countries. So it's not that big a mystery. There's got to be, these have to be sources of lead exposure in all these countries with lead exposure then getting entrained into the various ecosystems. And to understand that, we need to actually partner with folks around the world to actually measure those. So I think this initiative, which I'm very happy now to base at the University of Southern California, and we have some seed money to launch this initiative. We have collaborators at NIH in the Fogarty program at NIH, and in folks all over the world, and of course collaborators at the GBD. Our aim is to develop a network of folks who can work on these exposure assessments and meeting other challenges in the GBD. And let me just mention a couple of things about the other challenges. One of them is, well, how do you prioritize the next set of pollutants that get into the GBD? Good question. Would have to actually partner with various risk assessors to model, well, what the likely distribution is globally, even though we don't have great data on that yet. And what are the major toxicities we have to worry about? And that's where some particular pollutants start floating to the top: arsenic, mercury, organophosphate, pesticides. Probably not too surprising for any of you. And then, of course, there are high production pollutants that we expect to be global pollutants over a rapid period of time because they're all over. Some examples: bisphenol A, phthalates, manganese is still used now as a anti-knock additive that's substituted for lead, which is crazy, since many of you know that manganese is also a neurotoxicant, but manganese is used as an additive in gasoline. And I think that on some level, if we are to go down this road and try to prioritize which pollutant gets into the GBD, we also have to be mindful of who our collaborators are. because this sort of shades into what IARC has had to do when it classifies carcinogens. It needs to carefully vet people for conflicts of interests who even get involved in these processes to predict or to estimate using the literature what the toxicity of various pollutants might be. Then here's a methodologic problem of the GBD, which is how to estimate the true impact of neurodevelopmental toxicants. The reality is that the GBD will only include lead's impact for those individuals estimated to have an IQ of under 85. Why? Because it's the global burden of disease, and losing 3 or 4 points of IQ is not considered a disease. Well, we all know that's crazy, because in fact, the health economists have a very robust literature showing how every point of IQ results in lost earnings and this, that, and the other, and they can show it, based on the literature. So we need better tools for estimating the true worldwide impact of neurodevelopmental toxicants, not necessarily based on the global burden of disease, but based on the global burden of lost human capital. And that's part of what this initiative is doing, is coming up with new metric tools to understand what the burden of disease might be. And here in this, this interesting analysis done by Dave Bellinger is that if you look at just lead as an example and compare it with all these other known impacts on lost IQ in the United States, lead is responsible for an estimated loss of IQ points of about almost 23 million, which is gigantic compared to all these other risk factors, perhaps only matched by preterm birth and a few other things. Okay. Okay. And in fact, in the GBD, we have developed new tools for measuring human capital, which could be brought into this conversation. And the GBD has already published some methodology tools on what this may look like. Finally, for the climate change question, it's not in the GBD. It started to accommodate temperature as a risk factor and also nitrogen oxides. But of course, the challenge of looking at all the other things, the disaster associated things, food security, even migration and all those from climate is a gigantic challenge. But in fact, the policymakers, once you bring up risk factors and environmental risk factors, inevitably come back with the same question for the GBD, which is, well, you don't have climate change in that. That's what we're worried about. Can you do something? And so there is a group of investigators who are trying to come up with methodology that can go into the GBD, particularly for its new forecasting initiative. It has a new initiative for doing forecasting of years life lost and other burden of disease metrics, which is new for it. The GBD up until now is only focused on what the current situation is of the burden of disease. And this is where I think climate change needs to be. Finally, I'd say that, particularly with some collaborators, potential collaborators here in places like the Schaefer Center for Health Policy and Economics, getting economic tools to measure the impact of whatever we're doing in environmental health, and particularly in the GBD, is a policy tool, an important one, because most policymakers, their eyes will glaze over when you're talking about, whatever it is that we're measuring, all these cognitive tests or, measures of cardiovascular function, but they do understand dollars. And that's where we need to be able to also translate our work. And when it comes to sources and dollars, as an illustration how complicated this may be, we did this whole exercise with the Environmental Defense Fund and the GBD Pollution and Climate Initiative in which we could clearly articulate what the impacts of things like air pollution might be. But when it turns out to the sources of air pollution in India, it turns out there are no fewer than 16 different ministries, national ministries, that were responsible for each of the sources of air pollution in India. And I was like, well, how are you going to get them all in one room and address this as a mega policy change that needs to be addressed for air pollution? So the stakes and the issues are complex, but you do have to start somewhere. And luckily, this is getting on the radar screen of the policymakers. The GBD and also some of our pollution collaborators like Pure Earth and the Global Alliance for Health and Pollution get invited Davos to talk about some of this work. And I think this is an opportunity for all of us. It may not be funded by NIH grants, but we're in the hunt for other funding institutions, and I believe that they will emerge because this is one of those global and national sustainability issues that have to be addressed. So that's two domains of things that be very interested in working with folks to develop collaborations. This one is a global collaboration opportunity, and I look forward to hearing from you.
Well, thank you, Howard. Giving us a lot to talk about. I'd like to take the remaining 10 or 15 minutes to open it up for questions from anybody of the 60 participants that we have attending this interesting lecture. And so either you can just, yes, please, go ahead. I'm sorry, Dr. Mustafori. Okay. Well, happy to entertain any question from anyone. Either raise a hand or just start talking.
I have a question. This is Megan. I was curious, Dr. Hu or Howard, with the balance between environment and mental health. I'm wondering if you think there's room. I know that if I recall, the global burden of disease doesn't typically include mental health, but with your point about environment and neurodevelopment, now more and more links coming out with various pollutants and mental health risk and severity, I'm wondering if you think that's somewhere that, or a new avenue that could be added in the future.
Okay, first I'm going to close the door because the house cleaners are here and they're vacuuming, so hold on a second. Real life intrudes in our Zoom home formats. Okay, so in fact, the GBD has a whole bunch of mental health outcomes. But I guess the major point to be made is that the GBD is not a vehicle for doing etiological research. I mean, what it does is simply collect statistics from all over the world and then puts it through these various machines and complicated algorithms to get them all expressed in the same scale, and in terms of risk factors, for getting each risk factor, it's called risk factor outcome pairs, entered into this complicated model so they can all be adjusted for each other, right? So you get these essentially population attributable fractions of disease from this risk factor, from that risk factor. So it's not a vehicle for doing that kind of research, although what it could do actually, because it's standardized all these metrics of disease, is that you could do superimpose ecological studies if you have some really good hypotheses and perhaps some low-hanging fruit opportunities for ecological analyses that are not, for whatever reason, are not subject to the usual horrible biases that they might be subject to. But there's sort of natural comparisons of different regions that are very similar to each other, but for whatever environmental risk factor you're kind of interested in. Then, gee, maybe it can be used for sort of generating hypotheses from ecological research. But there is a lot of mental health outcomes in there. And in fact, you know, one of the first insights that GBD made when the first iteration came out many years ago was that the number 2 burden of disease that is causing disability adjusted life years in adults was depression. And that was a huge eye-opener for the world community, because up until then, it's like, oh yeah, it's gotta be cardiovascular disease or cancer or, you know, whatever. And it really started this kind of a revolution in some countries paying much more attention to mental health, which was great. You know, that was a good part of it.
I had a question, which, how do you actually measure a bone lead level? Do you need a bone sample, or is it difficult?
Yeah, it's a scanning instrument. It's basically more, it's non-invasive, it's very safe. The radiation dose is less than 15% of a dental x-ray. It's very small. And it's sort of like the bone densitometry machine that measures, you know, grandma's bone density. It uses a cadmium-109 source to shine photons at your bone target, and then the outer shell electrons fluoresce, and it's not an ionizing radiation, so the electrons don't escape, but they emit these fluorescent photons that then get counted. They put on a spectrum, and the job of the software is to sort of discern the lead peak from the background peak and extrapolate the area under the curve. And then we normalize it to the area under the curve for calcium. So the metric is actually units of lead per unit calcium. And that turns out to be very highly correlated with micrograms of lead per gram bone mineral. And that's how it's calculated.
And Howard, could you say something about, you've described a couple of very exciting studies, both the element study and the GBD related work. Can you say how investigators who have either ideas or interest in participating, contributing, offering suggestions, what's the clearinghouse venue?
So I did present sort of the mechanics of how Element operates and the resources it had at the working session we had earlier this morning. I'll make that slide deck available. The last few slides has some notes about, you know, how we operate. Basically, there's an executive committee with the senior investigators, myself, Karen Peterson, Martha Diaz Rojo in Mexico, and several others who, you know, are PI of various grants. So, you know, it's a whole mixture of PO1s and R1s and R21s and Ks that support this research. It was one of the children's center things, but that's being phased out, as you know. Cheer, Echo, it's all part of the whole thing. You know, we have a whole submission form for folks who would like to analyze their data. And I got to say, one of the things I said this morning is that there's just so much analyses that could be done that we've just never gotten around to do. I mean, there's so many great hypotheses to test. And we would welcome folks who are interested. You know, that slide deck also has some general domains of inquiry that are currently funded. So you can create your own if you want. So that's true. And as the GBD, it's just forming now. And if I ever get time to actually initiate my own research here, I will create a website, hire a postdoc, and create the tools so that folks can get involved. But the humor aside, no, you can always just shoot me an email and be glad to tell you what can be done as part of this initiative and the folks who are currently involved.
Great, thank you. Talat, did you have a question?
Yeah, Howard, you've talked a lot of metals and other things from the element study. And in Mexico City, air pollution should have been a big issue also. So have you looked at indoor and outdoor pollution? And especially you have kids, like infants, their growth, like physical growth, not mental?
Yes, so we have lots of physical growth measures of the kids. We've done some research on anthropometry, not only birth, but the growth trajectories. We also have lots of measures that abdominal circumference and other things to look at. We're very interested in obesity. There's a whole set of investigators looking at metabolomics and metabolic syndrome as an outcome. Obesity is a huge problem in Mexico, so we're right in there looking at that and endocrine disruption and blah, blah, blah. Now we've measured, have measurements that will allow us to look at non-alcoholic fatty liver disease. I discussed a little bit of that this morning. We have bone density measures in the mothers now, a whole bunch of other things. We do have air pollution now, but it's outdoor, mostly from kriging techniques and using the outdoor monitors. Maria O'Neill has done that research. Mexico this population hasn't had much in terms of indoor air pollution. They've all, non-biomass, the usual low pollutant type of sources.
Do you have occupational health, occupational workplace, et cetera, information on the mothers that are in the element study?
We do have some information on that. Actually, we did a whole nother investigation, occupational investigations using our bone lead instrument for printing press workers who are still using the old lead linotypes, automobile radiator workers, and that sort of stuff is going on all over Mexico City. So we do have some occupational data, not a heck of a lot, not that detailed, I would have to say. But I will say also that Mauricio Hernandez Avila, who is our initial collaborator, is now also the Director of Occupational Health and Social Services for EAMS, which is the national organization that provides health insurance and services for all people in the private sector. So we're talking about over 25 million people. And he's eager to collaborate with us. So those for folks who are interested in occupational health, he's really eager to find folks who are like that, who are interested in working with them.
Great. Other questions in our remaining few minutes?
I had a question.
Please go for it.
Hi, Howard. This is Diana Union. I was wondering if you or anyone on your team has looked at if there's a correlation between the bone lead and the air pollution in the element cohort, or what the correlation is.
Yeah, we haven't, but we would anticipate that there would be a correlation, particularly for the older mothers, given that combusted leaded gasoline was such a major vector for lead exposure in Mexico. On the other hand, it's not necessarily the dominant one. One of the other major sources of lead exposure among our residents, unfortunately, is the continued use of lead glazed ceramics, which the nation is just getting around to sort of address. It's a significant source. I was telling the story this morning of in the late 1990s. I'm still a clinician, and myself and one of my pediatric colleagues had to treat the U.S. ambassador and his whole family because they were in Mexico and received a ceremonial, big sort of vase gift as a gift, and he stuck this punch in there and served it over the holidays, and they all got lead poisoned. And it's terrible, right? That was a pretty stark lesson on how this is still a exposure issue in Mexico.
Okay, well, thank you. Let's see, one more quick question.
Yeah, one more question. Hi, Howard, I'm Mustafizu. So what are the plans for CBD team to improving the estimation of outdoor air pollution associated?
So, I'd have to say that the outdoor air pollution work is probably the most advanced, as you can imagine. It's led by Mike Brower, who many of you know is an air pollution expert at University of British Columbia. Now, in the past year, he's morphed into a dual appointment, partly at UBC and partly at the University of Washington. And he's the one who's leading the team that deals with all of the pollutants that are currently in the GBD, outdoor, indoor air pollution, lead, radon. He's the one I work with most closely in our initiative, which is outside of the GBD, and working on various projects to tee up things for the GBD, but that have lots of other things to do besides just that. You know, as I mentioned, the GBD, they're pretty rigid in terms of some of their methodology. They're not going to stray from their paradigm of only looking at cognition if the IQ is below 85. They're not going to change that. But, you know, we'll do our own thing when it comes to neurotoxicants and neurobehavioral impacts. So depending what you're interested in, for air pollution, because it's already in the GBD, you'd probably go to Mike and his team if you have some ideas. But if there's for a pollutant that's not in the GBD yet, come to me and I'll tell you who to work with.
Okay, we're about out of time. I just want to thank everybody for participating and remind you all that next month, November 6th, we will have Linda Birnbaum, the former director of the NIH Center, of the NIH Centers, and the whole program nationally to talk with us about her work in PFAS and her general perspectives on research, given her many years of oversight, both in the NTP program, National Toxicology Program, and leading NIHS. So thank you all. Please do get in touch with Howard and follow up on some of these ideas for collaborative work in either of these studies that he's talked about. And thank you very much, Howard, for sharing some of your insights with us.
Thanks so much for having me.
Thank you.
See you guys around.